about CBR here. Uh, Maybe actually the as per your GT lab, he has not included this experiment in your syllabus. So that's the major that's the major mistake he has done, because this is very important test, California bearing ratio test. Yeah, moving to the experiment here. So what you need to do, this table, whatever you see here, it may be whatever the compaction you do, it may be light or heavy compaction. So after that, the same procedure, whatever you do for the compaction, the same procedure, take the mold. I'll try to explain the procedure in a brief way here in the virtual itself. Take the mold, as already mentioned, spacer disc below should be inserted into this mold, and on this mold you need to transfer the soil. So what, a tray is there. On that tray, you know how much weight of soil should be taken. You know your volume of the this mold. That volume into whatever the density gamma d you got. If you do, you'll get the how much amount of soil should be taken, around 5 kgs if I say. So that 5 kgs of soil you have taken in a tray, okay, and you have added how much amount of water, you got optimum moisture content from the compaction test, whatever you've done is something like 20%. 20%. So for example, here whatever you've done, volume into dry density you've done, you got something like 4,500 grams or 4.5 kgs is the soil. So 4.5 kgs of soil passing 20 mm should be taken. To that, 20% should be added. 20% means around, I can say it as around, that is for 2500 means around 1000 ml we may get, around 1000 ml you may get, around 1000 ml or 1500 ml of amount should be amount, because weight is high. Now the weight of the soil is more. Mix that soil and do it heavy compaction only. Always go for heavy compaction, because we usually construct the roads on national highways, state highways more when compared to rural roads are very less. If under any schemes like PMGSY scheme, then only go for rural roads. So 5 separate portions has to be made of the soil which you have mixed correctly, and place those in 5 layers. In 5 layers in this mold, in 5 layers, and each mold you should give how much? 56 blows. 1, 2, 3, right? 4, and another is 5. That's why the height of the mold is 17.5 centimeter. So 5 layers. Each layer you have to give 56 blows with the help of heavy rammer of 4.8 kgs. What you need to do after that, you need to rotate this completely. And you need to remove this spacer disc. So 5 layers will come in this way, and above this you need to place some weights. Circular weights will be there, that you need to just put it. 2 circular weights, each of 2.5 kgs. And those circular weight will be something like this, round, and in between a circle will be there. Between the circle, the plunger will be penetrating in that way. So we need to note down the penetration values. So for example, I'll be showing here. Here you can see some photographs. These photographs I got from my during my MTech work. So you can see this is the setup actually, CBR setup. You can see the same. You can see it in your GT lab also. So this is the mold, right? So this is which I'm talking about. This is the plunger. Here you can see the plunger has been penetrated into this mold, right? This is the dial gauge which measures the penetration, and this is the proving ring which measures the load, which how much load is been applied for each 0.5 penetrations. I can say for 0.5, you can see for 0, 0.5, 1, 1.5, you need to note down. So whatever the CBR value you are getting at 2.5 is whatever the value you're getting at 2.5 is the CBR value of the soil. 5 also, that is the CBR value of the soil. So proving reading, you need to note down here in this column, and you need to convert this proving ring reading into loads, that is in kgs. If any corrections are there, you need to do the corrections. And later on, unit load for 2.5, it is 1370 kg per centimeter square. 1370 kg per centimeter square is the unit load. ఇది యూనిట్ లోడ్ ఎలా వచ్చిందంటే, వాళ్ళు ఒక స్టాండర్డ్ మెటీరియల్ తీసుకొని వాళ్ళు టెస్ట్ చేస్తే 1370 is the unit load. అలాగే 5 mm దగ్గర 2055 is the unit load. That is unit load when I say, that will be unit is kg per centimeter square. మీన్స్ ఆ 5 centimeter circle కి ఇక్కడ ఉంది కదా, this will be 5 sorry, this will be how much, that is 5 centimeter dia, 5 centimeter ఏరియాకి 1370 kg is the unit load for that is for that area. 5 centimeter, that is 5 centimeter. If I talk about circle means pi d square, right? So pi d square a area ki 1370 is the unit load. And similarly at 5 mm ki inta load, standard load. So whatever is there, this load for every 50, zero, first zero దగ్గర ఎంత లోడ్ ఉంది, జీరో దగ్గర ఇక్కడ ప్రోవింగ్ రింగ్ లోడ్, ప్రోవింగ్ రీడింగ్ జీరో ఉంటుంది. 50 దగ్గర ప్రోవింగ్ రీడింగ్ ఇక్కడ ఒక వాల్యూ వస్తుంది, అది రాసుకోవాలి, తర్వాత కేజీ కన్వర్ట్ చేయాలి. So here you can see in the above image, I am doing the heavy compaction. You can see this is the bigger hammer. This is the bigger hammer. Here you can see some blue color, right? That is rapid moisture meter, we say. So this is the hammer, and you can see the mold, which is bigger mold, right? So this is how you need to note down the values. So I'll be showing the formula to you. Yes, here. And you need to plot a graph, that is penetration for every zero. For example, from 0 to 0, 0.5, 1, 1.5, 2, 2.5, later on 3, 3.5, 4, 4.5, 5, like that. And versus unit load. As already mentioned, 2.5 ki 1370 kg per centimeter square. 5 ki 2055 kg per centimeter square. Here is the formula, CBR in percentage. That is, in the numerator, you will be getting unit load carried by a sample at a defined penetration level, divided by unit load carried by a standard crushed stone at the above penetration level. So for 2.5, it is 1370 kg per centimeter square, or you can just say 70 kgs. That is the standard load. And at 5, it is 105 kgs. If you want, you can take it in kgs, or you can take it in, that is unit load applied on a area, that is 1370, and this is 105. So whichever is the higher, that will be the CBR value, and the CBR value is always represented in percentage. And what we need to do is, here this whatever this you are seeing, this mold completely should be immersed in water for 4 days. It should be kept in water for 4 days. That we set as soaking. So here you can see the two images here. These images are actually the just a minute. Yeah, these images are the extracted CBR soil specimen. You can see here, extracted CBR soil specimen here. Yes, you can see here extracted CBR soil specimen here in this way from this mold. If you extract, the soil specimen will look something like this. This is black cotton soil, and this is that is sandy gravel soil. Okay, so in this way we need to plot, and we need to get the penetration value at 2.5 and 5. That will be the CBR value. Usually what we say, what is the CBR value getting at 2.5? Usually what happens, if I say for black cotton soil, the CBR value will be within the range of 1 to 3%. 1 to 3%. For other very good soils like sandy gravel soils and all, the CBR value will be around 8%, 9% and all. If the CBR value is higher, then the soil is very good. If the CBR value is lower, the soil is very weak in terms of strength. Some limitations are there. That is, whatever the strength we are getting, this strength cannot be related to the cohesion or any other like shear strength and all. That is the disadvantage, limitation. Material should pass through 20 mm sieve only, whatever the materials we are taking, and whatever the surcharge weight we use here, which will stimulate the field condition. ఇప్పుడు ఏంటంటే సబ్ గ్రేడ్ పైన వేరే లేయర్స్ ఉంటాయి. ఆ లేయర్స్ లాబొరేటరీలో చూపించాలంటే మేము వెయిట్స్ పెడతాము, 2 వెయిట్స్, 2.5 kg వెయిట్స్. సో అది ఒకటి లిమిటేషన్. అంటే ఫీల్డ్ లో వేరేది అవుతుంది, ఆ వెయిట్స్ ఇక్కడ లాబొరేటరీలో సర్చార్జ్ వెయిట్స్ వేరీ అవుతుంది. తర్వాత సోకింగ్ ఫర్ 4 days, అది ఒక అన్రియలిస్టిక్. ఎందుకు 4 days సోకింగ్ చేస్తారో తెలియదు, కానీ 4 days సోకింగ్ ఎందుకంటే, why the 4 days soaking is been done for worst condition. If the water mainly in some areas where there will be more rainy and all, there where the subgrade will become completely wet and it will be always saturated condition. That's why we will consider soaking also. Worst condition we say soaking in the water. Last second point is CBR depends upon the density and moisture content of the subgrade soil. That is what CBR mainly depends upon the whatever the compaction test results you are getting. Last is whatever the design is based upon the weakest subgrade soil encountered. So weakest subgrade soil if you are getting, then we need to reject those soils. We need to take a good soil. There is another test, that is field CBR test. We say there is no proper procedure available, but I got this image. So field CBR test will be conducted similar to the laboratory only, but with the help of manually we will be doing, like this is the probing ring which measures the load, and later on that will be, just a minute, yeah, and this will be the below plunger. You can see these are the plungers what I am talking about, small plungers. These are of different sizes. So this is the surcharge weights which I'm talking about. You can see a round circle is open at the middle. So these are the surcharge weights. So this, with the help of the hand, we will be penetrating this plunger on the soil and will be noting down the loads. So this is field CBR test we say. Laboratory, automatically the CBR, whatever the loading machine is there, that will penetrate the plunger into the soil, the mold. Coming to the next is next bearing test, that is plate bearing test, or we usually say it as plate load test. And this is the setup. See in the exam also, if he asks you to write about CBR test, you need to write what are the equipments required, what is the procedure, and that simple formula, whatever CBR in percentage I've shown in the formula, that formula you need to write. Coming to the plate load test, this simple sketch you can draw. So what happens, this plate load test is usually conducted, we said as plate load test or plate bearing test is conducted to determine the bearing capacity of the soil. Here what happens, this is the reaction. This reaction is usually provided with the help of any lorries. So lorry, what happened, the whatever the lorries will be there, this for example the below the lorry, this complete setup will be provided. So whatever the weight of the lorry trailer which carries the sand and all, that weight will act as a reaction. Or else what they will do, a plate will be there, on that they will put some sand filled bags, they will put, that will also act like a reaction there. And later on, these are the three plates, we set as stacked plates of decreasing of diameter. Like lowermost will be the of diameter of 75 centimeter, and this is 60 centimeter, and this is 45 centimeter, and if required you can also use another plate of 30 centimeter. And this is the hydraulic jack, means because of the reaction, what happens, this plate will settle into the soil. Settlement, we say settlement of the soil, and the settlement is being recorded with the help of this probing ring attached here, and the deflection with the help of this dial gauge attached here. So this is the plate bearing test setup or plate load test setup. So procedure is simple. The test site is leveled and the plate is properly seated on the prepared surface, and stiffening plates of decreasing diameter, as already mentioned, the lowest is 75, above that 600, above that 45 centimeter, above that 30 centimeter, in that way. Jack and probing ring assembly is set up. 3 to 4 dial gauge are fixed on the periphery of the plate and measures the settlement. First, we need to provide the seating load. Seating load, that is 320 kgs for on the that is 75 centimeter dia plate. And later on, we need to apply the load gradually, which causes a settlement of 0.25 mm. 0.25 mm always. And the rate of settlement will be 0.025 mm per minute. So if you want to do a settlement of 0.25 mm, means how much 10 minutes is required to get this this amount of settlement. So the load readings are taken for every 0.25 mm settlement of the plate into the soil. So procedure is repeated till 1 point, this I will write it as 1.75 mm settlement is reached. 1.75 mm settlement is reached. ఇప్పుడు ఏంటంటే ప్లేట్స్, ఫర్ ఎగ్జాంపుల్ ప్లేట్స్ ఇలా నేను ఒక డయాగ్రామ్ డ్రా చేస్తే ప్లేట్స్ ఇలాగ ఉంటాయా, సో ప్లేట్స్ ఇలాగ ఉంటాయి ప్లేట్స్, రైట్. సో ప్లేట్స్ ఇలాగ ఉంటాయి. సో ప్లేట్స్ కూడా ఒక థిక్నెస్ ఉంటుంది, ఆ థిక్నెస్ పెనట్రేట్ అవుతూ ఉంటుంది. సో ప్లేట్స్ ఇది 75 సెంటీమీటర్ ప్లేట్స్ సరేనా. ఈ 75 సెంటీమీటర్ ప్లేట్స్ దీనికి వచ్చేసి దీనికి ఒక థిక్నెస్ వచ్చేసి ఒక 5 సెంటీమీటర్ ఉంటుంది. 5 సెంటీమీటర్ దాంట్లో ఎంత 5 సెంటీమీటర్ ఆర్ మేబీ 1 సెంటీమీటర్ ఉంటుంది. 5 ఆర్ 1 సెంటీమీటర్ ఉంటుంది. 1 సెంటీమీటర్. ఈ 1 సెంటీమీటర్ లో ఎంత 0.175 సెంటీమీటర్ సెటిల్ అవ్వాలి. సాయిల్ లో వెళ్ళాలి. అప్పుడు స్టాప్ చేయాలి. సో ఫర్ ఎవ్రీ 0.25 mm ఆర్ 0.025 సెంటీమీటర్ కి లోడ్ ఎంత ఉంది ప్రోవింగ్ రింగ్ లో చూడాలి. We need to plot a graph, that is mean settlement versus mean bearing pressure or load, which we will be measuring in the load. That and we set as K value. This is the formula. K is equal to P by delta. It is P divided by 0.125. So this K is nothing but modulus of subgrade reaction. Remember, K modulus of subgrade reaction is P by delta, or we can set as P by 0.125. And the unit for modulus of subgrade reaction is kg per centimeter cube. Here you can see clearly again this one. We need to plot a graph, that is settlement versus the load or pressure. So you'll be getting in this type of graph. So we need to calculate the subgrade modulus of subgrade reaction using this formula. So remember, this is the formula, that is modulus of subgrade reaction. The unit is kg per centimeter cube. So what happens, some worst subgrade soil, because of worst moisture content, the settlement will be more. So we need to do corrections. So the correction is capital Ks is equal to capital K, whatever you are getting, into small ps divided by small p. So correction for plate size also, if you are using smaller diameter size, not 75 centimeter large diameter size, if you are using smaller diameter size, see I have explained in terms of rectangular, there may be, we may use the circular diameter plates also for settlement purpose. So correction of the plate size, if you are using smaller, you need to do corrections. So the formula for the correction is this one, that is capital K is equal to K1 into A1 divided by small a. Capital K1 is equal to, I'll write again here, that is K1 into A1 small a1 divided by small a. What is this K1? K1 is the modulus of subgrade reaction of A1. What is A1? A1 is the small diameter plate. And what is this capital K? Here, capital K on the left hand side is the corrected value of bigger plate, that is 75 centimeter dia plates. So this is how we do correction if you are using only smaller dia plates during the plate load test. So this is one small example. Here you can see for better understanding how you will note down the values. For example, mean settlement ఇక్కడ చూడొచ్చు మీరు 0 తర్వాత 0.24 ఫర్ ఎవరీ 0.25 నోట్ డౌన్ చేసుకోవాలి కదా. లోడ్స్ ఇక్కడ చేసుకున్నాం చూడండి. 0 కి 0 ఉంటుంది లోడ్. సో 0.25 కి 460 kgs ఉంది. 0.52 కి 900 అలాగా నోట్ డౌన్ చేసుకోవాలి. సో వీ నీడ్ టు క్యాల్కులేట్ ద what subgrade reaction. So modulus of subgrade reaction for small diameter plates, that is the same formula P by delta, but P1. So 1490, what is this 1490? 1490, that is the P1 unit load. P1 is equal to 1490, because for 0.125 centimeter we need to do interpolation here. So you need to do interpolation 0.125 or 1.25 mm. So 1.23 ki 1480 ఉంది, 153 ki 1590 ఉంది. 1.25 means in between these two. We need to do interpolation. That value will be getting as 1490 kgs. So 1490 kgs will be the pressure, because whatever this modulus of subgrade reaction we are finding, that is at 0.125 centimeter or 1.25 mm. That's why for 1.25 mm settlement, how much is the load is there? That load will be taken here. That is small p, the numerator. So we'll get, I got the value as modulus of subgrade reaction 16.86 for smaller dia. So here is the correction. This numerical example is related to the correction. That's why I will determine the capital K using the formula small k1 into a1 divided by a. Small k1 value I have already calculated here. Small a1 value is what? 30 centimeter small dia plate divided by capital A. Small a is what? Bigger dia plate, 75 centimeter. So in this way we will, this is just an example. The numerical example also they may ask, I'll try to explain the numerical example again. So what has been given in this example, a plate load test was conducted on a soaked subgrade. అంటే ఇప్పుడు ఫర్ ఎగ్జాంపుల్ ఒకటి మీకు కాంపాక్టెడ్ సబ్గ్రేడ్ లేయర్ ఉంది. సోక్డ్ అంటే వాటర్, ఇట్ ఈస్ కంప్లీట్లీ వాటర్ ఆర్ ఇట్ ఈస్ sprayed with water. So on that subgrade you are conducting a plate load test, you are conducting during monsoon season using a plate diameter of how much, 30 centimeters, smaller dia. The load values corresponding to the settlement of this plate readings are given below. Determine the modulus of subgrade reaction, that is K, capital K, for standard plate. What is the standard plate? 75 centimeter dia plate, that is the standard plate. So these are the load values. So what is the formula for subgrade reaction? As already mentioned, capital K is equal to small p by 1.25 mm, 1.25 mm or 0.125 centimeter, right? So ఇప్పుడు 1.25 mm దగ్గర స్మాల్ p ప్రెషర్ ఆర్ లోడ్ ఎంత ఉంది చూడాలి. ఇచ్చిన టేబుల్లో 1.25 లేదు, సో 1.25 డిటర్మైన్ చేసుకోండి. దట్ ఈస్ వాట్ హ్యాస్ బిన్ డన్ హియర్. ద లోడ్ సెటిల్మెంట్ కర్వ్ is plotted on a graph similarly to the graph that is settlement versus load. So delta, that is 0.125 centimeter ki ledante 1.25 ki 1590 undi from the graph, or else you can do interpolation from these values. That is 1490 load is been applied for 0.125 settlement or 1.25 settlement. That's why we need that value. Okay, now since smaller diameter has been used, first calculate small, that is K1. K1 means modulus of subgrade reaction for smaller diameter plate, that is 30 centimeter. So K1 value I got. Now we need to determine the modulus of subgrade reaction for standard plate of 75 or 70 centimeter dia. The formula is what? That is correction formula. Capital K is equal to K1 into small a1, that is small a1 divided by small a. So if I do, I'll get that is modulus of subgrade reaction for standard plate. So this is how you need to do the numerical examples if they ask in the exam. So thank you. This is about the soil here. So I'll move back to the next aggregates. Yes. Okay. So I'll move back to the aggregates here. Yes. So next is materials. Next material is what? Stone aggregates, right? So coming to the stone aggregates here. So what are the different tests on road aggregates? So if you see the syllabus also, he has given test on soil, test on road aggregate, test on bitumen. That is all about unit 4, is all on the tests related. So what are the tests here? Aggregate impact value test. Yes, aggregate impact value test is there. Later on, aggregate crushing value test is there. I have put the laboratory machine images here. Later on, shape test is there. Specific gravity and water absorption is there, right? And later on, abrasion test is there. So these are the tests which I am going to discuss. Total 5 tests. Test on aggregates now. Okay, moving to the test on road aggregates. So I have listed out here again. Test on coarse aggregate mainly. Aggregate impact value test, aggregate crushing value test, loss angel abrasion test, specific gravity and water absorption test, and shape test, that flakiness and elongation index test. Yes. Moving to the aggregate impact value test. See, I will be trying to explain briefly here, and I will be trying to show you the video, and I will be trying to share the same video with you again. So I don't want to waste much time because you already learned about the test on road aggregates in your highway materials and concrete technology lab. That's why I don't want to stress more here. So I'll move directly to brief explanation and showing of the video immediately, maybe for 2 minutes here. Okay. So I'll move to this, the experiment aggregate impact value test. So this test is being conducted to determine the toughness property of the given aggregates. And this is the aggregate impact machine which is used. So I'll try to move to the experiment. And here we require sieves. Only 2 sieves are required. In the bigger sieve, we require 12.5 mm and 10 mm sieve. and in smaller sieve we require 2.36 mm sieve. And the aggregate impact machine, this machine will be having two molds here. This is test cup and this is cylindrical measure and this is tamping rod. And this is the rammer of 14.5 kgs. Using this rammer, we should give 15 blows, 15 blows. So I'll be showing the videos here directly. Just a minute, I'll try to take the arrow. Yeah. So, okay. Hope the sound
students, so today we are going to discuss about aggregate impact value test. So the aggregate impact value test, the aim of this experiment is machine. So there you can see the line 2 and coming to the height 1.2 and coming to the diameter, that is inner.
So I'll try to mute the audio and I'll try to explain now itself. So this is a cylindrical measure. That is a cylindrical measure in my right hand, and later on that is test cup. This is test cup. So this is a cylindrical measure. So I try to move to the experiment directly here. So 12.5 and 10 mm sieve is been taken here. So 12.5 sieve. So you can see the sieve numbering also 12.5, and another is 10 mm sieve here. Right. So these two sieves. So we need to take the aggregates on this and we need to do sieving. And this is the smaller sieve which we will be taking, that is 2.36. These are the apparatus here, 2.36 sieve. Okay, so I'll move to the procedure here. So I've taken the I will be pouring the aggregates in the sieve here, right? And I will be doing the sieving. And after sieving, whatever the aggregates retained on 10 mm, that will be corrected. What are the aggregates retained on 10 mm here? And a weighing balance of minimum 5 kgs, tamping rod. So this aggregates, I will be weighing first. I'll move to the procedure. Yes, so now say I'll take the cylindrical measure.
Or you can also say it as a cylindrical measure. So I will pour it in 3 layers. So first layer, some aggregates. Or in simple words, I can say 350 divided by 3. So it will be near to 110 grams. You can see closer. So as I said, near to 110 grams. So, and I will give again the second layer 25 blows. So the blow should be given with a free fall. You should not impact it. You have to give a free fall. So 3 blows has been completed. So third layer, whatever the aggregates left out, so pour all those aggregates into it, into this.
So 3 layers, each layers you need to give 25 blows in the cylindrical measure.
Cylindrical measure and compact it. 7, 8, 9 aggregates axis. So you can just try to level it using the tamping rod. Comes as will be our M2, that is mass of test specimen in cylindrical measure. Or you can take directly the whatever the aggregate crust weight, cylindrical measure, test cup. All at once and later on compact it only once. It is compact only once, about 25 times. It is stamp only once in only once, because the hammer, whenever it gives blows to the aggregates available in the test cup, so this test cup may move aside or it may come out, so you should tighten it correctly. So now moving to the blows, number of blows to be given to the aggregates in the test cup is 15 blows. You have to give 15 blows using with the help of this hammer, 38 centimeter. So that free fall is being predefined. So okay, and this meter has to be made 0, and this meter now it's showing 15. between each blow less than a second should not be done. For example, first blow and second blow, the interval should be more than 1 second, not less than 1 second. So better I will start, first place it here, hammer on the aggregates, and I will do the first blow. First blow, second blows has been given, and the interval between the blows should not be less than 1 second. Undergone an impact load and has been crushed. So this aggregates undergone impact load should be sieved through the smaller sieve, as already been mentioned in the apparatus, 2.36 sieve. The sieve. So that we say it as M2 or M2. So 2. So next we will move to the observation and calculation. So here you can see aggregate impact value test, observation and calculation. So the aggregate impact value. So this is a simple equation. You can use, no need of getting complicated. Simple equation, 100 into M2 divided by M1. So what is M2 and what is M1? So here you can see, for example, for a trial 1, M1, or you can also say it as a W1, is mass of test specimen. What we have taken? 350 grams. And also M2 or W2 is mass of test specimen passing 2.36 Indian Standard C, which is 70 grams. So we got M2 and M1. So substitute in the given formula for aggregate impact value. So we get 20%, and the aggregate impact value should be expressed in percentage. So we get as aggregate impact value of trial 1 is 20%. So similarly, the aggregate impact value of the second trial we have done, and the aggregate impact value of second trial is 25%. Since the aggregates are of same, because of the compactive effort while giving the number of blows to the each layer, that is 25 blows to the 3 layers in the cylindrical measure, the compactive energy may vary. That's why we may get a different aggregate impact value. So always you need to do minimum of 2 trials or a maximum of 3 or 4 trials. So I have done trial 1, which has got an aggregate impact value of 20%, will be 22.5%. So this is my average aggregate impact value, 22.5%. So this is how we can conduct the aggregate impact value test and do the note on the.
Yeah, that's it. So that is what you can just go through all these videos. Yeah. So again, I put the slides also here. Testing machine, the cylindrical cup, hammer, cylindrical measure, tamping rod, weighing balance, and the sketch of the aggregate impact machine here. And theory I have put, test procedure also I have put here for better understanding, and also observation I have put. Okay. So whatever the M1 there I got is actually, first we need to take the weight of the whatever the cylindrical measure is there, W1 empty weight, and that filled with the aggregates in 3 layers, each layer 25 blows. So if you minus these two, will be getting directly getting the M1. Will be directly getting the M1, and this you can take it as M2 directly. That is M2 by M1 into 100. Simple. M2 by M1 into 100. 100 for percentage. Or you can use this formula also. This is still more simpler to understand. Okay, so results, coming to the results. So based upon the results, we'll be saying like if less than 10% is there, exceptionally strong in terms of toughness, and 10 to 20% means stronger. So and 20 to 30 means satisfactory for road surfacing only, that is top surfaces. Because what happens whenever you use the aggregates below, that is below the bitumen layers, immediately after the subgrade, their aggregate should have a good aggregate impact value. More than 35 we should not use usually. And even for different layers we have the values also, like what specifications here, waterborne macadam base course with the bituminous surfacing is there, then 40 is the maximum allowed aggregate impact value. For cement concrete base course maximum allowed impact value is 45% in that way, right? So moving to the next, crushing strength. So the crushing strength again remains the same here. So crushing strength, again the sieves remains the same, 12.5 and 10 sieve, and smaller sieve 2.36. But here the mold sizes changes. Like cylindrical measure of bigger size should be taken of about, this is about 11.5 centimeter dia and 18 centimeter height. And this is the test mold, open on both the ends. And we should use the CTM machine for this, because here the compression load will be applied to determine the crushing strength of the test. So aggregate crushing test, the next experiment here, I will be directly showing you the that is the last, because observation directly.
Hello students. So second experiment is aggregate crushing value test. So the is it is 18 used in the board left, right, and free form. Uniform in the sense on all the surface.
Here also we need to take in that three layers, and each layer 25 plus. Whatever the aggregates retaining on 10 should be taken in this cylindrical measure. So I'm taking here, you can see second layer has been poured, and second layer has been compacted with the help of the tamping rod, giving 25 blows. Third layer is also compacted. So you need to take the weight of this. So you can see the weight of this, how much I'm getting, you can just check here, 6.45. Okay. And also empty weight has been already taken. See empty weight, you can see empty weight. Now I'm taking the empty weight here, which is of 3.8 kgs, I think. So 6.8 and 3.8, both if you subtract, so this is the empty weight. So both you will subtract, you will get the M1 value, that is weight of test specimen. So that is what M1, that is weight minus MT. So this complete aggregates, that is in 3 layers in this test mold again. 3 layers in this test mold has to be done. Again, 25 blows to be given for each layer. And this that plunger should be placed on the in the test mold. You can see that plunger should be placed in that way, and you should level it. And the complete setup should be placed in this CTM machine to operate compression load of 400 kilonewton. I'll be forwarding. Sorry. So 400 kilonewton has been applied here. You can see 400 kilonewton has been applied. 40 kilonewton per minute is the rate of application. So I'll open again. Whatever the crushed is there, that will pass through 2.36. So I'll get 249. I got 2.36 passing. That is